Hey everyone, it's Justin again. Elimination can be a very useful method for solving systems, but there's also a lot of steps to doing it correctly. Now that we've learned about all those different steps, there's only one thing left to do. Practice with solving systems using elimination from beginning to end. As you watch this video, I encourage you to pause at the beginning of each problem and see how far you can get without help. Let's go. Let's start with an easy example. What's the first thing we have to do? We have to manipulate the equation so that like terms are lined up. In this case, that's already done for us. So the next step is to multiply, if necessary, to ensure that a variable will eliminate. For this example, the y terms are already prepared for elimination. Next, we add the two equations together. When we do that, the y terms cancel, and we get 2x equals 20. We can finish solving this by dividing by 2, and we find out that x equals 10. Now that we know x, we can plug it into either of the original equations, then solve, and we find out that y is 3. So our solution is 10, 3. Don't forget, it's always important to check your solution in case you make a mistake. To do that, we plug the solution into both of the original equations and see if it works. For the first equation here, we replace x with 10 and y with 3, and then simplify. Both sides are the same, so the solution works correctly in the first equation. For the second equation, we do the same thing. We plug it in, and then simplify. Again, we get a true statement. Because the solution made both equations true, the solution is correct. This example is going to be a little harder. First, we should make sure that all the like terms are lined up, and they are. Next, we multiply to ensure that a variable will be eliminated. Neither of our variables are ready yet. So which equation should we multiply, and by what? Well, we've got two options here. If we multiply the bottom equation by 3, then the y terms will cancel. And when we combine and solve, we find out that x is -1. If instead we multiply the bottom equation by -2, now the x terms are ready to eliminate. And when we combine and solve, we find that y is -1. Because we were able to eliminate each variable and solve for the other, we don't even have to go through the rest of the steps. The solution is -1, -1. So let's check our solution. Remember, even though we had manipulated the equations a little bit before we could use elimination, we have to make sure our solution is correct for the original system before we change the equations. We plug in our point, -1, -1, and simplify. On the left, we get -5 equals -5, which is true. And on the right, we get 0 equals 0, which is also true. This solution checks out for both equations. This is going to be our hardest example so far. First, let's rearrange these terms so that they line up. To put x and y on the left side of the equal sign, we'll add 2x to both sides of the top equation, and we'll subtract 4y from both sides of the bottom equation. Now that the terms line up, we need to prepare one of the variables for elimination. Let's go with the x term. So what is the least common multiple for 2 and 5? If we multiply the top equation by 5 and the bottom equation by 2, we'll get +10 and -10 on the x term. So now they'll eliminate. We can combine the equations, then solve, and we find out that y is 2. Now, we can plug that into either of the original equations and then solve it. If x is -1 and y is 2, then the solution is -1, 2. All that's left to do is check our solution on the original system. Plug in -1 for x and 2 for y, and then simplify. For the first equation, we simplify and we get that 6 equals 6, which is true. And on the right, we get 5 equals 5, which is also true. The solution to this system is indeed that x is -1 and y is 2. Now you know how to solve systems using the elimination method, in addition to graphing and substitution. Keep practicing all three methods because there will be situations in which each method is preferable over the other two. In the next lesson, we're going to learn how to tell when a system has no solutions or infinite solutions without even having to graph it. See you later.